So today we talk about the sine law, so start chapter 8. So how we're going to start is I'll pose this question. So we have a triangle given 2 degrees on one side. We're asked to find the length of A. How can we go about doing this? How can we go about trying to solve for A? Pardon? Go down the middle?
Yeah, so it's 2 right angles.
So we did learn something from yesterday. So I can't just do, I just can't do like tan or 45. Is equal to opposite, which is A over 30. Not a right angle, right? So right angle triangles are awesome because the trig ratios are pretty easy to deal with. Unfortunately, a lot of things in life don't happen at exactly 90 degrees. So we can't do this as much as we love to.
Why would it be A over 30?
Because I try to do opposite, which is A, and this is my adjacent side, 30. Right? Or maybe it's my hypotenuse, so I'm using sine. Right? I mean, I saw some of those attempts in the last unit test when we're given a triangle like this, and we're trying to solve for A.
I was just confused because A was O. You know, like I thought A was opposite.
A is opposite.
Yeah, but it was
The 45.
Adjacent.
Okay,
You know what I mean?
gotcha. I gotcha. So we're gonna do what Michael said. The last class we started, in solving that one question, we draw a line straight down from the vertex. So then we have 2 90-degree angles there. We could split that triangle into 2. So we have a red triangle here. A green triangle. Okay, what do these 2 triangles share? What do they have in common? They're both right angle triangles, yes, but what else do they have in common? That is clear. Yeah, they share one of the side lengths, right? One of the side lengths is common to both triangles. So we're going to label this H, or like the height of a triangle. So same as that solution we were working at, so let's just focus on one triangle at a time. Let's focus on the left because we know 2 or 3 pieces of information there, right? So what do we know about the left?
That the hypotenuse is 30.
Good, so we have the hypotenuse.
And we know all angles.
So maybe I should use H. Maybe H is better. I'll call this X. So here we have the hypotenuse of the triangle. Right, we're given an angle. What else we started dealing with? Sorry?
Figure out all the angles.
Well, we can't quite figure out all the angles yet. I mean, we don't know what this angle is. Well, actually, we can. So that would be 45 as well. Oh, that was a fluke. So that could be 45. So what can we do with this?
We can do sine.
Sine of
45.
sine of 45. So you know what? I'm just going to write sine the equation first. So sine of theta is opposite over hypotenuse. So which is our opposite side? The 45. It's this one here, right? So sine of 45 is x over h. In this case, it's 30. So can I isolate for x? Can I solve for x?
Yes.
So what's x here? Well, don't worry about it yet. Yeah, so 30 times the sine of 45. So we could get an answer, but you know what? Let's resist and get an answer for now. We just know that that's what x is. What can we do with the green triangle now?
now we know what x is. So we can
Sure.
so we can just do
Well, let's start simply. What was this going to work with?
Right.
Sorry? What are we going to work with?
60
60,
and
x.
value.
the x, and probably what we're interested in, a, right? So what's the relationship between those three? Sine, right? So sine of theta will opposite over adjacent. So in this case, theta is 60. The opposite side is x.
It's opposite over hypotenuse.
Oops. Thank you. And the hypotenuse is a. So similar to what we did last time, we're going to say, well, x is equal to a times the sine of 60. Does anybody see where we're going here?
I see how. I don't
Anybody
like
see what we could do with this now?
Don't we have like the same variable and then you put like 30 sine
Yeah.
43 and then a sine 60.
So, I mean, it's basically what you were saying before. We know the value of x, right? So we're just going to sub it in. But basically here we got two equations. X is equal to this. X is equal to that. So this is equal to that. So we got 30 sine of 45 is equal to a times the sine of 60. So how do we solve for a here?
Right?
How do we solve for a?
Divide the right side by sine 60.
Only the right side?
Both sides.
Both sides, right? So a is equal to 30 times the sine of 45 over the sine of 60. So you plug that into your calculator, we get an answer. What do we get? Everybody have their calculators? Nobody brings calculators in math class anymore?
My brother took mine from my dad's again.
Good thing you didn't have a test today, huh? So 30 times the sine of 40, folks. Yeah. I'm not used to this calculator. 30 times sine of 45. Divided by sine of 30,
60.
sine of 60. 24.49 roughly. Okay. Is that clear?
24.
That kind of algebra sucks to do all the time though, doesn't it? If I give you a question like that, doing the triangle, drawing it, a lot of work. So what we're going to do is try to look at it from a different perspective. Alright? What happens if, and I want you to do this in your triangles, we have a special way to start labeling our triangle. So we're given a side A, little a, so we're going to label our sides with little letters. We're going to label our angles with big letters, like uppercase letter, capital letters. So we have a little a here. We're going to label the opposite, the angle opposite that side with uppercase of that letter. So we got big A. Okay? So here, if I was to call this angle big B, where would my little b be?
The hypotenuse on the right side.
Well, this side is 30, right? So that's B.
What are we doing now?
Sorry?
Oh, I understand what's going on.
I'm trying to demonstrate a way that we're going to start labeling our triangles. Okay? So we're labeling triangles with uppercase letters, and the sides of our triangles with lowercase letters. But we're going to get them to match. So uppercase letter is the angle. The side opposite is the lowercase of that same letter. So this is my vertex C, that's the angle C, which side is going to be little c, the opposite side. Okay? So what we're going to start doing here is I'm going to go back to what we got over here. Okay? Remember, everybody follow how we got that at one part where x equals this, x equals that? So we got these two things equal to each other. Well, I'm going to replace these with just our letters again. So 30 was what? B? Okay?
Tell me we leave this as our answer.
Pardon?
Tell me we would leave this as our answer.
You would leave that as your answer?
Like,
If I was to ask you solve it from scratch, I just want you the answer. But I want us to investigate something there. That will make your life a little bit easier. See? Because like I said, do you want to do this every single time I give you a question like this? Do you want to do this algebra? No. Okay? So we got B
you're not the case.
times the sine of which one is 45? A, right? Is equal to A times the sine of which one is 60? B. Okay? So we have an equation here. B times the sine of A is equal to sine A times the sine of B. Now with any equation, like what I preached to my grade 9s, you can do anything to your equation. Right? Two rules. If you do something to one side, you need to do it to the whole side. Right? So you multiply by 5, you multiply everything by 5 on that side. Plus, you have to do it to the other side. Right? Two simple rules. Keeping your equations true. So what I'm going to do is, on the left-hand side, I can divide by sine of A. Am I allowed to do that? Can I divide the left-hand side by sine of A?
Yeah.
I can do anything I want. I just need to do the right-hand side. So you just divide by sine of A, divide by sine of A. So what am I left with? I got B is equal to A times the sine of B over sine of A. Right? I just divided both sides by sine of A. I want the B equals that. Now I'm going to divide both sides by the sine of B. And then what am I left with? B over sine of B is equal to A over sine of A.
Why?
Because first, when I got from here, right, I divided both sides by the sine of A. So I'm left with B is equal to A times the sine of B over sine of A. Then I chose to divide both sides by sine of B as well. So now I get B over sine of B. Here on this side, the sine of B's cancel. I got A over sine of A.
I know, but like, why did you do that?
Just write it down. Write it down first. This is the sine law. This is a relationship. These are the ratios that will be true of all triangles. A over the sine of B, B over sine of B is equal to A over the sine of A. And by extension, if I was to do yet another thing like this, eventually will work out to be C is the same as sine over big C. And that is the complete sine law. You're thinking, yeah, so what? Is it easy to remember? B over sine of B is equal to A over sine of A is equal to C over sine of C. That's all you need to do to solve this.
So you use that for left hand.
They need to talk in French or something, Jordan? They need to talk in French. Don't make me do that.
So you could have done the last test.
We could have done that in the last test. If you knew the sine law. Actually, a couple of kids who did know the sine law did do that on the test.
equals C. What the heck is this?
You done yet, Christian?
Yeah.
Okay, so what I want to do is just from scratch, draw a fresh new triangle. So I can hit it. Draw a fresh new triangle. This is the same triangle we had before, so draw it fresh. This time we're going to leave out the numbers. And we're just going to label it with the letters that we talked about. So like what Elizabeth doing, you just pick one of the vertex, label it, just go straight across and label it with the same letter, right? The order doesn't really matter. What you call A, what you call B, what you call C doesn't matter as long as the opposite side matches the angle. So this is the sine law. You just roll it down. Just want to highlight it again. So the sine law is little a over the big sine of A is equal to little b over big sine of big B is equal to little c over sine of big C. In other words, these three ratios are the same. Does that sound familiar? We did something like that already last unit that was very similar to this. Dealing with equivalent ratios. Yeah, similar triangles. Remember we had that thing, similar triangles? All the ratios were, so basically we're taking those same strategies and the math skills, but we could do it in a much larger application of solving for triangles. So that is the sine law. It can also be written as sine of big A over little a is equal to sine of big B over little b is equal to sine of big C over little c. You can use those two, either one.
How?
Algebraically, I'll let you prove why those two are the same.
Isn't it like a complete opposite? Or
They're
like
not
the ratios
complete
would be
opposite.
the ratios would be the same, but like
They're the same. Algebraically, it's the same. It'd be a challenge to go off and prove why they're the same. In other words, how do you get from the top to the bottom?
multiply by no.
How do you get from here to here? That could be a challenge. I don't have time to demonstrate that, but they are the same. So you can write the sine law one of two ways. Okay, everybody got that down? Could have memorized it by now. Okay, so how are we going to apply this? So here, solve the following triangle. What does solving a triangle mean again? Figure out all the sides and all the angles. Right? So this one's a little bit tougher because it's not a right angle triangle. So we want to round each side like to the nearest hundredth of a meter. So what's the first thing that we can sort of pick off right away? First thing to pick off right away.
We pick up the last angle.
Good. Right? We're given two angles of a triangle. We can always know what the third one is. What is that third one? How do we figure out the third one?
Well, 180. So
So 180
minus 83 and 26.
minus 83 minus 26. That's equal to, well, 83 plus 26 is 109. So this is 71 degrees. Okay. So that was the easy part. The hard part now is the side lengths. So we could do a whole thing, drawing this down, all that work. But we're going to take the easier way. Let's label our triangle. I'm going to call this A. Man, does it matter which one I call A? No. As long as I make the opposite side A as well. Then I'm going to call this B.
Wow.
So this would be B. And I call this C. So So this would be C. So what's our sine law?
A sine A or A equals
Sorry?
sine
A
equals over sine A
over sine of big A is equal to
B over sine of big B
is equal to
C over sine of big C.
good. And we just go and plug in our numbers down. Right? Do we know little a?
That's 53.
Good. 53. Do we know big A?
71.
Good. Sine of 71. Do we know little b?
No.
Nope. Do we know big B?
Yes, 26 degrees.
Good. Do we know little c?
No.
Nope.
We know little C. 83 degrees.
Good. So that's how we set up our equation, right? Very similar to what we did with similar triangles. So which one is our magic ratio? A ratio that we know for sure?
First one.
The first one, because we have no unknowns in here. So that's how we're going to solve for the other ones. So we got b over sine of 26 is equal to 53 over sine of 71. So b is equal to multiply both sides by sine of 26 over sine of 71. So b is equal to, my calculator. You have your calculator? Practice typing this up. 53 times sine of 26 divided by sine of 71. So it gives me 24 round to nearest hundredth. What does that mean?
Yeah, I'm so confused. So that's what. How do you do that?
53 times the sine of 26.
How do you do that? Oh, you multiply.
Well, sine of 26 is just a number, right?
Yeah, so you multiply both sides by sine 26.
Yeah, from here to here? Yeah, I just multiply both sides by sine of 26. So that's how I isolate for b.
Yeah.
And I'm just doing that on my calculator. So I encourage you, please bring your calculators to class. Work with these examples with me at the same time so that you know that you're plugging it into your calculator, same thing, and getting the same answer that I am as I'm going through my calculator. Nearest hundredth means how many decimal places? Thank you. So 2 decimal places, right? Don't want to lose silly technical marks because you didn't give me the right decimal places. And we do the same thing with C. So here 53 over sine of 71 is equal to C over sine of 83. So here I got C is equal to 53 times the sine of 83 all over sine of 71. So again, more calculator work. 53 times sine of 83 divided by sine of 71. And that gives us 55.64. Okay, so just remembering that formula, the sine law, allows us to solve for this type of triangles a lot easier, right, than doing all that algebra that we did before, because there's a relationship with those ratios. Okay, any questions on this example? We'll just stand up for a second. Stretch. Oh,
Can I get a drink?
get a drink. Jordan can tell us a little bit more about trip to France.
Yes. Let's do that.
I don't know. It was really fun.
What's the best thing that you ate there? That's all I care about.
Crepes with Nutella and whipped cream.
Crepes with Nutella and whipped cream. But I'm sure it was the crepes that made it good, not the whipped cream and Nutella.
Of course.
It was the Nutella of the jar, right?
Yeah.
Okay.
No, I had like one of those a day.
Oh, nice. Is this what you built it?
What?
Like the person that you stayed with, they made you that every day?
No, so for school we have like 2 hours to go out for lunch. But some days, since I didn't have to go to math,
Wants to go for lunch.
so like Tuesdays, me and the other exchange students would have 5.5 hours for lunch.
What?
5.5 hours.
Just like a whole school day.
Yeah, I thought school was hard over there. What's going on?
Well, okay, so at 10:30 they have computers, so there wasn't enough room for all of us. So we got to leave. Then they had 2 hours for lunch anyway. And then there's 2 hours of English, which we didn't have to go to because we already know how to speak English. So we took 5.5 hours every Tuesday.
Okay.
1 or 2 hours. So then we
Now
just
5.5 hours could have been used to do math, trigonometry, quadratics.
Just follow it. Never.
What time is the school end?
But some days at school ended at like 6.
Oh,
But Wednesdays we had a half day.
That's cool.
So
Every Wednesday?
yeah,
What?
we had like 3 hours every Wednesday.
To solve the problem by yourself, pause the video here.
That's so cool.
I want to wait till everybody was sort of done so that you can see sort of the strategy you're going to take with this question. I'm going to solve for, can I do anything with the e's?
No.
No, because they're both unknown. So I need to start with the d's. What am I solving for here? Am I solving for the angle or am I solving for the side? The angle. So remember we had those 2 ways to specify the sine law? If I'm solving for an angle, I want to do the angles on top because that'll make the algebra a little bit easier. Okay? So which one is my sort of like magic ratio? In other words, which ratio do I have where I know the angle and the opposite side? F. So here I'm going to have sine of F over F is equal to sine of 35 over 42. So there's my sort of like my magic ratio to solve for everything. So here I want sine of F over F is equal to sine of D. It's equal to sine of D over D. So that gives us sine of 35 over 42 is equal to sine of D all over 64. So we get sine of 35 times 64 all over 42 is equal to sine of D. So on the left-hand side, what do we get on your calculator, Elizabeth? 0.84? 0.87? It's sine of D. So this takes us now back to the last unit of how do we solve for D. In other words, if this was theta, it's the same question. Sine of theta is equal to this number. How do I get theta? What operation do I need to do? Yeah, I need to do the inverse of sine. So inverse of sine of 0.87, this smart board, is equal to D. And that gives us to be what? 60 point. So we want angle to the nearest tenth. So 60.5. Right, so D is 60.5. Wow, that is. Okay, so we have the angle D. How do we go solve for E now? Yeah, we need the angle first, right? Because we can't do a side length. How can we do the angle? Good. So we do the 180 minus 35 minus 60.5. What do we get?
What if you got 60.92?
I got 60.9.
You got 60.9? Oh, because did you use the full value on the
No.
left-hand side?
Wait, what?
Yeah, but it's so
Wait,
hard
I
to do
didn't
that.
round. I didn't round.
You didn't round?
I just wait.
You didn't round the left-hand side?
I didn't.
So you like the sine inverse of this whole thing?
I just like. I just log everything.
I didn't round and I got
At the end.
60.5.
You
I
did not round?
I did round and I got 60.9.
yeah.
I did
Okay, so there's going to be some issues about exactly what answer you get. Obviously, when I mark your exams or mark your tests, I have to adjust for both because you can round. I do allow rounding in the intermediate steps. If you don't round, that's okay. That's when you can have some discrepancy. Makes my life harder, but both are acceptable. Okay, so let's say we got 60.5. So what's this angle here then? So that's 95.5 under 80 minus 84.5. Yes? Now we could do the other side. So when I'm doing a side, solving for a side, which version of the sine law am I going to use? Yeah, the side on top now. So here I'm going to have sine of f over f. No, I want the sine on top. So f over sine of f is equal to e over sine of e. So f is 42 over sine of 35 is equal to e over sine of 60.5. So e is equal to 42 times sine of 60.5 divided by sine of 35. So e is equal to, the calculator, 42 times sine of 60.5 divided by sine of 35. 63.73? No?
I got 72.
Or about 72.
Oh, what? I divided by the wrong sign. Divided by sine of 35. Oh, what did I do wrong there? 42 times the sine of.
It's not 60.
It's 84.
Oh! 84.5. Thank you. That's what I went wrong. So that gives me 72.89. Is that better? So this is equal to 72.89. Is that everything? Is that all the sides and all the angles? So that's that. So it's just really remembering that equations applying it. It's all ratio work. Ratio. R-A-T-I-O. Be careful. Any questions on this example? No? Okay, well you actually have like 15 minutes to do homework.